submodule video, submodules 3 and 4, we're going to be diving into some of the background information you need for those analyses, um, specifically the phylogenetic analyses. So within submodule 3, after we have analyzed our dd-rad data and uh, and now have aligned sequence data, we can put that sequence data through two different common phylogenetic tree inference methods. One, the concatenation method, and two, a coalescent method. And so we create phylogenetic trees with IQ tree, which is what we use for our concatenation method, and SVD quartets, in which we use um, it, uh, to model coalescence within this group. And so when building phylogenies from rad-seq data, the choice of method, this concatenation method or coalescent method, can have an impact on how we interpret these evolutionary relationships. So like I said, there's two commonly used approaches, and there are many different types of approaches, but these are the two that we're using today. IQ tree 2 will allow you to use it, or it's a concatenation-based method, and it works by combining all of the loci into a single supermatrix and then inferring a tree based on that combined data set using maximum likelihood. The advantages of this approach include fast and highly optimized inference, strong statistical support, especially with many loci, and allows for complex models of sequence evolution. However, concatenation assumes that all loci shared the same evolutionary history, and this assumption may be violated when incomplete lineage sorting or gene tree discordance is present. So in that case, we use SVD quartets, which is a coalescent-based method that analyzes unlinked SNPs or short sequences to build a species tree from quartets, which are groups of 4 taxa. The key advantages include accounts for gene tree discordance by ILS. It doesn't require concatenation, and it is well suited for rad-seq datasets where each locus is short and potentially unlinked. There's some trade-offs, like SVD can be computationally intensive for large datasets. That's not the case with ours. And the other thing I just wanted to briefly mention was the concept of ILS, or incomplete lineage sorting. And so when we're looking at multiple different loci, if we assume that each loci is evolving under one certain model. That's not the case that we see in a lot of times. A lot of times we see different trees reflecting different histories. And so we could have a case of coalescence where our gene tree reflects the species tree, or we can have this case of incomplete lineage sorting where the lineages have split in a different way than the species tree. And so this is where we like to use quartet or multi-species coalescent approaches to try to account for incomplete lineage sorting. And then finally, in submodule 4, we're going to be plotting these phylogenetic trees that we create. And so R is an excellent choice to create these publication quality phylogenetic figures. And we'll go over a few different ways to plot them, such as plotting the phylogeny on a map if you're interested in biogeographical analyses, or similarly looking at gene tree discordance between two different tree methods. And so in this case, we have our SDV quartet and our IQ tree, and we can look at the discordance from that.